permutations and combinations, and in which now we are basically entering into the first segment of the chapter, that is the permutations. Okay, now what it exactly means, see the result. I have 5 students, and out of 8 students, 8 choices are available with me, and I want to arrange the any 5 students. Now arrangements are there, and we have 8 choices. Okay, so number of ways we can arrange the 5 students from 8 students. Okay, these many are the choices, but we want to arrange any 5 students. Okay, so basically if you read the question, there are 2 digits, 8 and 5, and we are considering the scenario that n is the greater value and r is the lesser value. Clear? So you have to decide the 2 values, and then you will get this number of ways. Why this is important? Now we'll see a simple thing. If I could give you the question that form a meaning, a word with meaning or meaningless words from the letters of the word Raj. How you will do it? Will tell me the possible result of the arranging the letters of word Raj. Please quickly in a chat box, not so difficult. Arrange the letters of word Raj in the all possible ways. In one message, a complete answer. Arrange the letters of word Raj quickly. Nitra, test is open to you. Last weekly test. It was assigned you properly.
Yes, yes, ma'am. I completed it.
Okay. Thank you. So arrange the letters of the word Raj. Okay, Anil Dev is answering 3 factorial. Why? How you answered 3 factorial? Can you please explain me?
Yes, ma'am.
It's a correct answer. Now see, with the logic also you can solve. A Raj letter is of 3 letters word. Okay. To arrange the first place, we have how many chances? 3 ways. Let's consider I just fixed J over here. If I consider any one letter over here at the first place, how many letters are left with me? 2, right? Then I am fixing the second letter. So how many letters are left with me? 1. So it is 3 into 2 into 1. Getting clear? With the fundamental principle of counting, we are getting 3 into 2 into 1, and it is nothing but 3 factorial. Okay. So that's why the permutation of the word Raj is 3 factorial, means how many ways? 6 ways. So one student can smartly work. Now I'll take the example of another kind of student. He will do it orally. R-A-J, J-A-R, R-J-A, then J-R-A, then A-R-J, A-J-R. So 1, 2, 3, 4, 5, 6. Clear? So this is also an answer, but how many times you can do it? We need a proper formula for such things. Yes or no? If I give you the word mathematics, then it will be of 11 letters. So is it feasible to work on such things by this simple logic? No. So that's why there is a case where arrangement of the n object r object out of n objects given, okay, which is known as a permutation. Clear? Now let's start with our PPT for today. So same technique we have to use today for the complete solving of all questions. Very easy session. Now I have the 8 students, out of which I want a placing of 5 only. Clear? So it is nothing but 8 permuted with the 5 places. Clear? Okay. Now this is the solving. Now what is exactly how many number of ways to do this task? So number of ways to arrange the 5 students from 8 is given by 8p5, which is 8 factorial upon 3 factorial, which is equal with 8 into 5 into 4. Clear? Now multiplication is 160, so there are 160 overall ways. Now forget about the calculations or process. Till now you are not aware with the formula. Clear? Okay, that's why you are considering that the 160 ways are there to arrange these things. Okay, clear? Now same thing is there in the day-to-day life. We want to arrangement of password creation. You know that lock where we have a passwords of 3 digits. We are trying various combinations 012, 213, 210. So we are setting one password. So such a kinds of scenarios are there, or RTO's case which we have seen in the last. Every digit is different. Every number is different. How many arrangements are possible? How the things will be known just with the permutations. Clear? Okay, so these are the all uses of the permutations, a very wild branch. Now, what we need to recall fundamental principles of counting. What are the fundamental principles of counting? Addition and multiplication, right? Okay, union is concerned with addition or multiplication theorem. Fundamental principle of countings are not CR, that are combinations, which we have not seen yet. Okay. Addition and multiplication. Now what is union? What is intersection? Union means addition and intersection means it is denoted by word or, and letter is a intersection which is denoted by multiplication. Clear? Okay, factorial notation. Factorial notation, in that I have given you the homework. Quickly tell me all factorials. Who will tell me directly? Up to 10. Up to 10 you are supposed to do the calculations. Okay, 6 factorial, 5 factorial, 120, fine. 6 factorial, 720, good. Five zero four zero for 7 factorial, okay. 8 factorial, 40,000 and 320. If you want your calculations to be very quick, okay, for Okay, so remember this table as in how we are remembering the tables for the lower standards. We are remembering a multiplication table. Now your grades are upgraded, so you have to remember the factorials, at least 10 factorial, up to 10 factorial. Okay, that will be beneficial to you to have a quick calculations. Okay, so this is about the factorials notation which we need to recall. Now what we are going to see today, what is permutations, what is a meaning of that notation, NPR, properties of NPR means permutations and important result on permutations. Okay, so permutations means you have to remember that arrangements. Okay, but though we have the permutation session today, but I will make you understand with respect to combinations first. See, I want to select one monitor out of the 5 girls and 2 boys. Okay, or we'll take a 4 boys and 3 girls, out of which I want to select a one monitor. What is the property used over here? Selection. Okay, and next example I am giving, in my class I have a 5 boys and 3 girls. I want to arrange them in a row. Clear? I want to arrange them in a row. So what the difference you are finding in two questions? In the first question, sequence doesn't matters, right? No. Is there anything which is related with the sequence? No. I have a data of 8 or 5, and out of which I am just sorting out one. Okay. So it is a no arrangement related question. But the below question is related with the arrangement, and hence it is exactly the difference between the permutations and combinations. So in the first scenario, we can say that it is a permutations. Here we have a total data of 5, 4 plus 3. So 7. 7C1 and 7P1. Clear? Now, see, in the second scenario, I want to arrange all 7 students on all different 7 seats. It must require 7 seats, no? 7 students I am arranging, so it will require 7 seats, right? So we have the data of 7P7. This is the difference between permutations and combinations. Got it? Clear? With the simple word language, whenever there is a selection or crowd creation or team creation where the sequence doesn't matter, it is a exactly question of combinations. Okay, and whenever there is an arrangement is important, and already in the question only the word arrange is used, that is important for permutations. Okay, so this is difference. Now see the permutations, each of different arrangement which can be made by taking some or all number of things is called as a permutation. Now, in the sum textbook, that the definition is given as arrangements of n objects out of r objects given is known as permutations. That is also fine. Okay. But here I have changed my definition that each of the thing which we are arranging is a permutation. Why? Because permutation can be linear or circular. Clear? Arrangement of anything, any assets will be mainly in the linear manner or maybe in the circular manner. Clear? So the both definitions are true. So basically you need to write down in your notebook permutations. Now we are looking for the first type of permutation. Write down arrangement of n objects, sorry, r objects out of n objects given. Arrangement of r objects out of n objects given. Clear? So it is a very clear result that n is always greater than r. This is fine. Yes or no? You can't arrange, I want to arrange the 4 girls out of 7. Is it possible? I want to arrange 7 girls out of 4. Is it possible? I want to arrange 7 girls out of 4. No. Is we are going to divide the girls into 2 parts? No. So this can't be a possible case. So that's why n is always greater than r, or it may equal with r. Clear? Okay. N is greater than r, or it may equal with r. This is an important fact about the permutation. If you take it in a reverse order, that will be very harmful to you. Okay, clear? Now, fine. So in this case, we have the different scenarios, and hence the different cases will be considered. Now, just write down types of permutations. We have this in a next lecture actually. All types will not be covered in one session. So write down first one. Linear, distinct, and non-repeated. This is a core permutation which is arranged in a linear manner. Distinct objects are there and non-repeated things are allowed. The second one, we have a linear kind of permutation. Then objects are also distinct, but it can be repeated. Okay. In the third case, we have a linear permutation. Objects are identical. Okay, so if objects are identical, we have the case, different case that repeated and non-repeated will be same. Clear? So linear and identical is the third type. And the fourth one is the circular permutation. So we are covering this first and second in the J1 session, J2 session, that is today. And third and fourth will be covered in the third only covered in the next session, and fourth will be covered in the next then after session, that is J4. Okay, clear? But these all things are permutations only. Clear? Up to this is clear what we have to learn. Now just understand the difference. Write down in your notebook. Make this chart. This is a very important part. NPR is equal to n factorial upon n minus r factorial. Here permutation NPR is equal to n raised to power r. For repeated one I am talking. Here NPR is equal to n factorial upon p factorial into q factorial into r factorial. Clear? So where PQR are identical. We'll see it in details in next lecture. Just write down the difference of formulas. Okay. Then fourth one, permutation in a circular way is n minus 1 factorial, or if direction is considered, then n minus 1 upon factorial upon 2. This is with respect to direction, and second one is without direction. Okay, clear? So these are the all formulas which are related with the permutation. So by reading your question, you have to identify whether it comes in type 1, type 2, type 3 or type 4. Clear? Once you got the scenario, now it's very easy, because in this session we are going to think on first and second type only. Yes or no? In the next session we are going to think on third type only. Then next section we are going to think on the fourth type only. But what if I give any question in JEE 2024 when you are attempting it in after your 12th? You must know that I have to categorize it either in first, second, third or fourth. Clear? Okay. So these are the all important four types of the permutations. Now let's understand the first one, which is the extreme important formula, meaning of NPR. Number of permutations of n distinct objects taken r at a time is denoted by NPR. Now NPR is equal to n factorial upon n minus r factorial, where r can be any value which is lying between 0 to n, and resolution is in a reverse order can be written as simplification of such identity can be written as n into n minus 1 into n minus 2 up to n minus r plus 1. Clear? So now the question is, there are some shortcuts. Okay, the important shortcut is NPN. What do you think? What will be the answer? N factorial, because denominator is getting 0, right? I'm not visible to you, Achaya. Your video is not visible, but I am visible and audible to you. This issue happened with you in the last session also. Okay, so just clear it out after session. Okay, so just remember NPN shortcut is n factorial. So directly tell me, if I have 21 things to be arranged at 21 places, what you will directly write over there? 21 factorial. Clear? Clear? What will be the answer of NP0? NP0 is what? Only one way will be there, no? I have anything and I am arranging 0 thing out of that. So that is done with the only one way. Clear? So NP0 is always equal with 1. Clear? Most of the time this is not an is useful case, but we'll still take it. Okay? Now, done. Let's understand some of the properties of the permutations. So here NPN is n factorial, NP0 is 1, NP1 is n, NPn minus 1 is n factorial, NPR is equal to n into n minus 1 PR minus 1. If you have to do it with the shortcut at any of the case, these properties are important. Don't take this in a picture. Third and fourth are not so important, but the values of first and second will be frequently used. Clear? Clear properties of NPR. Got it? Clear? Okay. Now I'm giving the questions, miscellaneous questions to solve. Quickly solve this one. 51P 49. What you will do to solve? Should I show the calculations of in one question? See, I'm showing over here. Let's take in question of 27P 25. So what will be answer? Sorry. 27P2 will take. So it is 27 factorial upon 27 minus 2. So that is 25 factorial. So it is 27 into 26, 25, 25 gets cancelled, and whatever the answer of multiplication, that will be your final answer. Clear? So 702 will be your final answer. Clear? This is I am showing. Now take it for your reference. Just solve this one with the 4. Well, 4 or 3. Take it 3. 51P3. Everyone done with the same answer? Okay. Now, so there is no shortcut for multiplication, but still you have to use your common sense only. Whatever the 10 multiplied terms, you have to take a single digit calculations and just put 10 over there. Okay, clear? For example, I want to multiply 12 into 20. So what I will do? 12 into 2 I will do and just put an extra 0. Clear? So that is a multiplication shortcut everyone knows, and that is not your standard 11th content. But for NPR, I will explain the shortcut. Check it. How many terms are there as an R value? 3 terms are there as an R. First start with this. 2 terms are there as the reverse order 2 terms of 27. 27 into 26 will be your answer. Clear? Okay. Here I have a 51P3 means what? 51, 50, 49. I just required reverse order 3 terms multiplication. That will be your permutation. Clear? Okay. Now everyone ready for the next question? With this method, quickly solve. Okay. Just tell me answer, don't multiply. 27P4. What will be the answer? 27P4. Only multiplication. Which value will multiply? Quickly in the chat box. It will require hardly 1 second to think upon which will be the terms to be multiplied. 27 into 26. 27 into 26 into 25 and into 24. 4 terms you are multiplying. Good. Now I want 101 P5. What you will do? 101 P5. What you will do? Quickly. Good. So this is a shortcut for the permutations. Got it? Clear? Now, next one. Some important result of permutations. My clear thing for you is if you are confusing with this result, don't remember. If you want to do extra, something extra with respect to JEE, don't forget this result. Okay. Now, the number of permutations of n different things taken are at a time, and a particular thing will be always included. Whatever the things, but if there is an extra statement added in your situations that a particular thing is included, then we have to use this formula. Clear? R into n minus 1 upon P R minus 1. For example, form a 4-digit number with the digits 1, 2, 3, 4. Okay, form a 4-digit numbers with the digit 1, 2, 3, 4 such that 3 is always included. This is the same case. 3 is always included. What you will do? R value. What is the R value over here? 4, and n is also 4. So what you will do? 4 times of 4, 3P3. Get this result by calculation also, but this is an extra shortcut. Clear? So if 1 is always included there, then also answer will be same. 2 is always included then also, because we are seeing the particular one thing condition which is always included. Clear? Okay. Next one. Number of permutations of n different objects are taken at a time when a particular thing is always excluded, never taken. If 3 is never taken, then what will be answer? 3P3, right? No? So it can't be working over here n minus 1 PR, so it will be coming 3P4. For it is not possible. Clear? So it must be, for this scenario of digits, it must be 3p3. Clear? Okay. So next one, a number of permutations of n different things taken all at a time when m specified things are always together. I want two girls together. Means my value of m is 2. Clear? I want two boys together. Then my value of m is 2. Clear? So with including this m value, we'll get this result m factorial into m minus m plus 1 factorial. Clear? Then next is the m specified things never come together. We want the arrangement of a letters of any word such that vowels will not come together. And we have a vowels 4 values. Okay, that means my m value is 4. Clear? So vowels never come together. If the case is like this, never comes together, you can easily use this formula for permutation. Clear? The number of permutations of m different object taken r at a time when p is less than r, particular things are always included, like 5 values are always included. So p will be 5. Clear? So these are the miscellaneous result. You can prove this miscellaneous result by foundation concept also. Okay. So if you have no capabilities to remember these formulas, don't remember. Okay. But these are a shortcut trick for the students who are genuinely preparing for JEE and with the great preparation. Okay. Clear? Now we are done with the theory part of the permutations. Now do you want a break? Okay, so we'll allow 5 minutes break and then we'll continue with the solving part. Okay, clear? Hello everyone. Let's get back to the calculations. Solving part. Everyone? Okay. Now we have provided the ratio NP6 upon NP3 which is equal with 120 by 1 means 120 only. So what is the value of satisfying value of N? You will solve this with the formula. We need to expand, nothing else. NP6 upon NP3 is equal to 120. This is a given data. So try to solve. Therefore, n factorial upon n minus 6 factorial. Similarly, n factorial upon n minus 3 factorial is equal to 120. Right? So, n factorial upon n minus 6 factorial reverse multiplied with n minus 3 factorial upon n factorial is equal to 120. So, n factorial gets cancelled. So, n minus 3, n minus 4 and n minus 5, n minus 6 factorial upon n minus 6 factorial is equal to 120. Now, we need to resolve 120 into 3 consecutive terms. So, n minus 3 into n minus 4 into n minus 5. 12 into 10, that we know. So, it is 6 into 5 into 4. Clear? N minus 3 is the biggest one and n minus 6 factorial is the smallest one. You must understand this concept, then only it will be clear to everyone. Cleared? Solve and tell me the value of n. What happened, Achaya? This is the correct answer, no? If you consider any factorial, any factor, middle factor, then also it is getting n is equal to 9. Or if you compare with the n minus 5 is equal to 4, then also you are getting n is equal to 9. Clear? All the result, but don't compare all at a time, no need. Just one comparison will give the answer. Clear or not? Yes or no? Okay, so try the second one. Wow, so easy. 12 PR minus 2 is to 11 PR minus 1 is given as 3s to 14. Try it, everybody. I want your answer now. Bhuvna, is it clear? Mokeshwaran, Ashwin, Netra, Achaya, Kanishka, Anil Dev. Okay. Now try this one. Everyone is getting this answer? Everyone is getting R is equal to 6. See the calculations. These are the calculations for R. In the last example, we have placed the calculations for N. That's why they are observing somehow critical. Now, reversible method is applicable over here also. First identity is 12p. Everyone have your attention on screen. I'll explain you the calculations. Hope you are solving the same. Everyone got 6. Netra, Achaya, Ashwin, Mukeshwaran, Bhuvna. Okay. Kanishka, Anil Dev done with the answer. Okay. Now see. 12p r minus 2 upon 11p r minus 1. First thing in mathematics, whenever you are applying a 2-digit number to the 1-digit number, like r value is given in 2 terms. So apply bracket. Clear? That will be okay. But come back. Go out of the class, but come back if you are facing network issues. Now, r minus 2 is placed in bracket, r minus 1 is also given in back bracket, so that minus minus will get plus. Clear? So after applications of formula NPR is equal to n factorial upon n minus r factorial, we are getting the answer 14 into 12 factorial upon 14 minus r factorial and 3 into 11 factorial upon 12 minus r factorial. And if you compare this number, this one is bigger number and this one is smaller number. Clear? I have placed all bigger numbers on the one end. So 12 factorial is bigger, hence divided with the 11 factorial. Here 14 minus r is bigger, that's why it is divided with the 12 minus r. Clear? Okay. Now, I just missed this 3 first of all. Then after rechecking the calculations, I got to know that this 3 is missed. So if I shift this 3 on this end, we are getting 2 consecutive options, that is 8 into 7 as the multiplication of LHS. Clear? After comparing the highest number with highest only compared. So I am comparing 14 minus r with 8. So we got the value of r is equal to 6. Clear? Okay. Now, Next one, you will try this one. Try. This is find the value of a. Okay. If m plus ap2 is equal to 56 and m minus ap2 is equal to 12. Okay. So try with the ratio only. You will get a simple answer. Try with this ratio m plus ap2 upon m minus ap2. Now it will be reduced. Okay. We'll do one thing. We'll take a divisibility of 6 over 6 2s are 12. Try it. Meanwhile, I'll just make you understand with the lowest values. So ratio will be converted with the easiest format 7 by 3. Try with 7 by 3. Okay, try. So this one will be 3 times of m plus a factorial upon m plus a minus 2 factorial. It will be 7 times of m minus a factorial upon m minus a minus 2 factorial. Yes, no? Got it? This one, everyone got this one? Okay. Now if you could multiply the brackets, then also you will get answer. Okay, we'll do one more thing. Pay attention. We'll take it with the another method. It is taking with the complicated. See here, everyone have your look on the text given over here. Find the value of m and a. If these two equations are given, we'll solve it one by one. Let's, instead of ratio, let's take it with the one ratio with respect to one equation and another equation. Clear? So first let's solve, take the value of possible m and a value which are possible over there. Now 56 is direct answer given and two constants are asked. How will be the permutation of first equation? M plus a p2. What will be the permutation of first equation? Therefore m plus a factorial upon m plus a minus 2 factorial will be equals with 56. Clear? So it will be m plus a and m plus a minus 1. So what will be the 56 if I compared with the two nearest numbers? What will be the 56? 8 into 7, right? So I am getting a first equation as, therefore m plus a is equal to 8. This is my equation 1. Got it? Clear? This is the first possible solution. Now let's solve second one. What is the second one? M minus a p2. So m minus a p2 is equal to 12. Therefore m minus a, I am directly taking permutation with the shortcut method. Clear? Is equal to 4 3s are 12. So we got the value of m minus a is equal to 4. Clear? We got equation 1 and 2. Solving equation 1 and 2, we will get the answer now. Solving equation 1 and 2. What is equation 1? M plus a is 8. And m minus a is equal to 4. So if I could add these equations, put it in any equation. Clear? We got the value of m is equal to 6 and a is equal to 2. Clear? Whenever your first method is going wrong, we are not getting anything common while we solve with the ratio method. Clear? So that's why we are changed our methodology of thinking also. This happens with you also in the JEE examination, that you are thinking in one way and you will not certainly getting an answer. Clear? Okay. So this is about the trial and error method. Obviously, sometimes it goes wrong. Clear? Now, let's try with the next question. How many number of integers greater than 7,000 can be formed using the digits 3, 5, 6, 7, 8 without repetition? Cases of without repetition. You will do it. You will try this, and this is a question of JEE 2023. Have some confidence in you that you are able to solve JEE 2023 questions. Clear? And it's a very easy question. Try to solve JEE 2023 question which was asked on the plane permutation. More than you, it requires more time for me to diagnose that it is particularly of this topic question, and then take it for you. You are solving. Try this one. 120. Can you explain why the answer is 120?
5 digits, so it's 5
Okay.
into 4 into 3 into 2 into 1 without repetition.
So you have taken 5 into 4 into 3 into 2. Then what is that extra case? Okay, so that is a plain case, no, Anildev. Now what is that extra case given that it must be greater than 7,000? Whatever you are giving me as an answer, 5 into 4 into 3 into 2. I am considering that I just started my number with 3. So 3,567, for example. Is it greater than 7,000? Is it greater than 7,000? No. Clear? Got it? So this is not a mistake. First time this happens, that thinking should be different now. Okay. Now what I am suggesting you, first thing 5 digits are given to you. Yes or no? Okay. So if I place up 5 digits on 5 places, obviously this is a greater than 7,000. So 5 factorial is one case. Clear? Case 1 is 5,000. That is fine. And now we need to add with the fundamental counting principle. Clear? Which is producing answer 120. So with case 1, I am getting an answer 120. Now what is the case 2? Let's consider case 2. If I want a 4-digit number, case 1 and case is also in detail. Okay, for your solving. So see, the two cases arises. Case 1, it is a 5-digit number. So when it is 5 different digit numbers arranged at 5 different places, it is 5p5, which is equal with 5 factorial, which is equal with 120. Clear? This is obviously a first case. So I am placing over here also. So 1, 2, 3, 4, 5. Okay. So this is having a 5 chances to fill. This is having 4 chances to fill. 3 chances, 2 chances, 1 chances. All chances are acceptable. Now case 2. Understand. I want a number greater than 7,000. What is the consideration in a box method? 7,000 is a 4-digit number. So I just made first option can be filled with either 7 digit only. I am talking either 7 or 8. Clear? Here, is there any other chance to fill? If I could fill it with the 5,000, is it fine? Is it worth? Is it acceptable for this case? Got it? So first place can be filled with the any 2 digits only, 7 or 8. Clear? So we have the 2 ways of filling first place. Now next one, in the second place, how many chances do we have? Think on this. No, any one. If I could log 7, what are the number of digits left with us? 1, 2, 3, 4. Okay, so 4 digits are left over here, then here 3 and here 2. Clear? So it is 2 into 4. I'm talking about the ways. Okay, so these are the 2 ways. This is extra knowledge. What are the ways? But 2 into 4 into 3 into 2. So it is 2 into 4 into 3 into 2. Clear? Second thing is clear. So what will be the answer? 48. Now, here the fundamental counting principles comes in the picture. Either the case 1 will occur or case 2 will occur. Clear? If you want a number greater than 7,000, either case 1 or case 2. So if it is or connective, then how many total number of ways? 120 plus 48. So what will be the answer? Clear? Clear? Please, I want a big smile on your face. Don't value rocket science. It's a simple plain mathematics of permutations. Clear, no? Okay. Now, So 160 will be, 168 will be your answer. Now let's try this one. The number strictly between 5,000 to 1 lakh. Sorry, 10,000. 5,000 to 10,000 can be formed using the digit 13579. So what will be the answer? Exactly similar to the last question. Only one case is not considered in that. Only one case is not available over there. Okay. See, a number less than a 1, 2, 3, 4, 5. A number less than a 5-digit number is itself a 4-digit number. What is the previous number less than the 10,000? 9,999. Right? No? So it is 9999. So it is a 4-digit only. Clear? So they are just confusing you. So we have to form a 4-digit number between 5,000 to 10,000. Clear? And excluding 10,000. We are not taking 10,000, and even we are not taking repetition because this is an important case. Without a repetition is measured. So what will be the case? These are the hints. Now available digits are 13579. Okay, fine. So I want to form a 4-digit number. Clear? What are the options for this place? Either 5 or 7 or 9. Clear? These are the options. Yes, no? For this place, any can be option. For this place also any can be option. For this place also any can be option. This is clear? This is clear? Now tell me the answer. This can be filled with the 3 ways. Okay, if I could log any number, let's log 3. How many numbers left with us? How many digits left with us? 1, 2, 3, 4. So we have 4 ways to fill this. Okay, if I could log any 2 numbers, then 3 ways to left this and 1 way. Clear? So we have now simply over here the case arising is 3 into 4 into 3 into 1. Clear? 3 into 4 into 3 into 1. Because we are not repeating the digits. If I could log any one certain digit, obviously that will be not coming once again. So we are not repeating. Clear? Now, let's consider without repetition is not there. Anyone can tell me the answer. Okay, first answer this one. 4 3s are 12. 6. Sorry, 2 will be left, right. 1, 2, 3, 4, 5. So here it is 4, 3, and 2 will be the last one. Okay, answer. Answer, please. 72. Okay. Now, I'm changing the JEE 2023 question for you. Just have attention. See, permutation combinations can be expressed in how many ways. Here only I am changing the question orally. I have this data, but I'm not considering this one word without a repetition. Without repetition word is not there. Repetition is fine. We just want a number greater than 5,000 to 10,000. Clear? And repetition is fine. What will be the change in the answer? Who will think on this? What will be the change in the answer? First place can be filled with 3 ways. That is a fine. Because we want a number greater than 5,000. How many chances are there to fill these places? repetition is allowed. So 1, 2, 3, 4, 5. Here also 5 places are allowed. Here also 5 digits are allowed. Here also 5 digits are allowed. Clear? So we have this answer as 3 into 5 and 2 5 into 5 if the case is of repetition is allowed. Clear? This is an extra thing. Whenever repetition is allowed, the factors can be repeated. So whatever the answer, but concept is clear. How 4? No, Anil Dev, it's 5. Though we have fixed 7. Yes, it's okay, but got the concept now? Okay. So it is 5, 5, 5 only because all the digits are allowed to repeat. Okay. Now, try this one. The number of 5-digit numbers greater than 40,000 and divisible by 5, which can be formed using the digits 0, 1, 2, 3, sorry, 0, 1, 3, 5, 7 and 9. First thing, whenever there is a question of digits, 0 is creating an scenario. Always. See, no, because if we have 0 in the digits given, 1, 2, 3, 0 is 4-digit number, right? No. But 0, 1, 2, 3 is not a 4-digit number. It's a 3-digit number. Because 0 is degrading the value when it comes at first position. That we know. Yes, no? So, for the first position, anyhow 0 is not acceptable. Now, see, to understand this question, first concentrate on the useful words, okay? See, I am going to solve this one. Number of 5-digit number, okay, so we want a 5-digit number. Greater than 40,000, find divisible by 5 is the important. And which can be formed using the digits 0, 1, 2, 3, 5, 7, 9 without repetition. This is an also important word, okay? Now, let's take a block chart of 5-digit number. What are the cases which are possible? Who will tell me this is first place, second place, third place, fourth place and fifth place? Who will tell me the divisibility of 5? What is the divisibility test of 5? Last position can be filled with 0 or 5. Right now, last data can be filled with the 0 or 5. These are the two cases. So case 1, 0 is at end and case 2, 5 is at end. Clear? Okay. So I'm considering here. Let's try with the my case 1. 0 is at unit place. Okay. So I am just blocking 0 over here. Clear? Now if I could block 0 over here, what are the digits left with us? 1, 3, 5, 7 and 9. 1, 3, 5, 7 and 9. Clear? Now what are the digits we can place at first place? Means thousands place. 4, greater than 4 is allowed. So we have either 5 or 7 or 9. Clear? Okay. So just the 3 values are left with us which can be filled with the, see, 0 is gone, any one is gone. So 1, 2, 3 and 4 left with us. So we have the 4 digits at 3 different places. Clear? So total answer when 0 is at unit place is equal to 3 into 4p3. Clear or not? Is there any doubt? Should I give you more explanation about this, or this is sufficient? Why that 3 times is fine? Got it? Clear? First place is filled with the 3 ways. Clear? middle place is 4 digits available and any 3 places are available. So 4p3 is a permutation of middle place and last place is already fixed with the 0. Clear? So we have 3 times of 4p3. Is there any doubt? I am again repeating. Is there okay? Now this is done for 0 at unit place. Now case 2. We are keeping 5 at unit place. So if I keep the 5 at unit place, what will be the answer? 5 is fixed over here. Okay. So what are the digits left with us? 0, 1, 3, 7, 9. Clear? So first place can be filled with the 7 and 9. Okay. And this one is what? 1, 2, 3, 4. So these are again 4p3. These are two weights. So it is 2 into 4p3. Clear? Yes or no? So either case 1 will occur or case 2 will occur. So try to answer now. Clear? How the answers come 120. Yes or see, complete permutation is logical and thinking capacities. And whenever you are coming for permutation lecture, please come with the some of the revision of previous one with the great level of understanding, with the great food before the lecture. I don't want your brain to be feel exerted because it requires hardest thinking capacity. Logical chapter it is. Done? Understood? Okay. Now, the number of 7-digit numbers which are multiples of 11 are formed using the digits 1, 2, 3, 4, 5, 7 and 9 is. Now you must know the divisibility test of 11. What is the divisibility test of 11? Anyone? What is the divisibility test of 11? In the divisibility test of 11, write down in your notebook only. Sum of even digit, sorry, sum of even digits minus sum of odd digits is equal to multiple of 11. This is the case 1 of divisibility. Second case, sum of odd digits minus sum of even digits, it is equal with multiple of 11. Clear? And the last case, okay, these are the two cases, means odd and even place difference. Now we don't know, no? Even place sum is greater or odd place sum is greater. That's why we have to consider either case 1 or case 2. Clear? Both the cases are clear. Now we want a 7-digit number. A 7-digit number holds how many even places and how many odd places? How many even places and how many odd places? Unit place is odd, this one is even, this one is odd, this one is even. First thing it is 7, no? This one is odd, this one is even, this one is odd. Clear? Got it? Clear? So we don't know which is the exactly case of this. Now we need to assume a one number over here. So let's assume a number which is a 7-digit number. Clear? Got it? Assume a number which is a 7-digit number. So it will be A, B, C, D, E, F, G. So if I put this one, so these are the 4 odd digit numbers. So in the combination of 7-digit number, I'll just make you the two cases possible. 3 even and 4 odd. Yes, no? This is the case 1, or 4 even and 3 odd. Clear? Okay. These are the cases. Sum of 3 even and 4 odd, or sum of 4 even and 3 odd. These are the possible cases. Up to this is clear. This is all about the hint of the question. Now, so write down, let the number be A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, 7. Okay. Let the number be A, B, C, D, E, F, G. Now, A plus C plus E plus G minus B plus D plus F is equal to 11x. This is our case 1, no? A plus C plus E plus G minus B plus D plus F is equal to 11 multiple, 11 times of K. Clear? Okay. Now actual sum, what is the actual sum given for our digit? What is the actual sum given for our digits? Add this one. Take a sum. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus, sorry, 6 is not there, 7. What is the sum of these numbers? Do it and tell me in a chat box. Okay, Pranav, you can continue now. What is sum? 31. Good. So we are getting a 31 as in sum. So pay attention. Now what are the proper cases? I want to resolve a 31 into two parts such that 31, one part is even and another part is highest odd. So it is only one possibility, that is 21 plus 10. Clear? 21 plus 10 is the highest possibility. So what are the cases arises? Case 1, A plus C plus E equal to 1 and B plus D plus F is equal to 10. And what is the case 2? A plus C plus E plus G is equal to 10 and B plus D plus F is equal to 21. Clear? These are only two possible cases. Now just find out the ordered pair, you will get the answer. Just find out the values of ordered pair. What is B, D, F will be to have a 10. What are the possible ordered pairs? If we consider a case 1, so we want a pair of 1 to 7 or 2, 3, 5 or 1, 4, 3. One, two, three, four, five, seven, 9. What I'll do? I'll keep this case apart. Okay, we'll make it later on. First, let's calculate for case 1. I'm erasing this part. Okay. Let's consider the possibilities of A, D, E, G ordered pair. What are the values for 4 numbers to be have 21? Tell me the possibility of A, D, E, G sum. 4 numbers which are producing 21. What are the possibilities which are out of these digits? Only these digits you need to focus. Just focus on these digits and tell me possible combinations where we can form the ADEG is equal to 21. ACEG is equal to 21. 1479 3459 2379. And similarly consider it for BDF also. One two seven 235 145. Yes, 145. Clear? So for BDF pair follow 10, we got these 3 pairs. This is clear? This is clear. So how many number of ways for case 1? Internally. Now see, these numbers can change their position. Pay attention, extreme attention over here. 1479. We are not telling like A is always 1. A is taking 4. So if A is taking 4, then anyone from C, E, F can take 1. Anyone from E, F can take 7. So this is the 3 times of 4P4. That is 4 factorial. Clear? or we can say 4 places and 4 digits. So it is a 4 factorial, and here 3 places and 3 digits. So it is a 3 factorial. So case 1 is producing 4 factorial into 3 factorial bits. Clear? First case is clear. Should I explain again? I know the some questions are always heaviest, but you need, if you could able to grasp that question, then believe the remaining question will be very simple for you. Got it? Just pay attention. In the first case, first I'm reading the question. The number of 7-digit numbers find, but given numbers are 1, 2, 3, 4, 5, 6, 7 digits, which are multiples of 11 are formed using the digits. Okay. So we want to form a 11 divisibility test. Now, what is the 11 divisibility test? Sum of even digits minus sum of odd digits may be the multiple of 11, or sum of odd digits or minus sum of even digits may be the multiple of 11. Clear? These are only two possibilities. We know which sum is greater. That's why these two possibilities are clear. Clear? Now, based on these two possibilities, just forget about these all things. We have one case that AC, if we consider the number is, or 7-digit number is A, B, C, D, E, F, G, then we need to add the odd places. A plus C plus E plus G minus B plus D plus F will be equal with the 11 multiple. Okay. Now what are the, with the capacities only we are able to think that with the common sense, highest even digit solution and odd digit solution for 31 answer is 21 plus 10. Why 31? Because our digits are forming their sum as 31. Clear? Based on this, we created a case 1. Case 1 is either 4-digit addition is even, odd, and 3-digit addition is even. And reversible case we have kept aside. So what is total solution? 4 factorial into 3 factorial. What is the answer of 4 factorial into 3 factorial? Do it. Okay. Now we are left with the case 2. ACEG is equal to 10 and BDF is equal to 21. You will guess the answer for this later on. How we have done for the case 1. So for case 2, answer comes 432. How it comes, think on it later on. Like splitting only, you have to come across with the same thing. And then in the case 1, we are producing the answer. In the case 1, we producing the answer 576. And in the case 2, we producing the answer 532, 432. Sorry, in case 2, we are producing 144 and 432, and addition is, so either case 1 or case 2 will occur. So what are the total number of solutions? 144 plus 432. So that will be 576. So you need to place numerical value question 576 as an answer. Think on these possible combinations. You will get the answer 432 in the case 2. And we'll try for the shortcut method in the next lecture if any available. Okay, clear? So This is the way of solving. Actually here I am to make you understand the way of solving. So cleared how you are going to solve this type of question? First you will check the divisibility of 11, and here in the 11 divisibility only the two cases arises. Okay, so either case 1 or case 2 is happening. That's why or is a connective, so total solutions will be added. Clear? Okay, now last question. The total number of 4-digit numbers such that each of the first 3 digits is divisible by the last digit is equal to. So we need to form a 4-digit number such that each of this digit can be divisible by the last digit. So let's consider we have a number ABCD. Clear? So let us assume the first case will be D is equal to 1, or D is equal to 2, or D is equal to 3. Clear? Then what will be fourth case? D is equal to 4, or D is equal to 5, or D is equal to 6, or D is equal to 7, or D is equal to 8, or D is equal to 9. These are the possible cases. Yes, no? We have 4-digit numbers such that each of first 3 digits means ABC is a different data, and D is what is that? D is the last digit and it is divisible by the last digit. Clear? Okay. Now for 1, what you will think? How many numbers, how many digits are there which are divisible by 1? All 10 digits are there, right? No? All 10 digits are there. Now here repetition is allowed. In this case, if the question is not given without or with repetition, always consider it with repetition. Clear? So all the numbers are divisible by the digits. So that's why we have the 9 into 10 into 10. Why? Because we are not considering 0 over first place. Clear? Okay. This is clear. Now, how many digits are divisible by 2? 0. In the divisibility test of 2, 0 is coming. Then 2 is coming, 4, 6, 8, and right now, so 5 digits are divisible by 2. So it is 2, 0 can't be at first place. So it is 4 into 4 chances of first place filling, 5 chances of second place, 5 chances of third place. Clear? Okay. Clear? Now, next one is 0 is divisible by 3. Count. One. Yes, no? 0 is divisible by 3. See, if you consider this pattern also, it is coming 3 into 4 into 4. A number itself, then 3, 4, 4. 3, 6, 9 are the 3 answer, and number plus 1, just do it like this. Whatever factors you are getting, just do it plus 1 for 0 or number itself. Clear? Okay. Then, a number divisible by 4. 4 and 8. Right now? 4 and 8. Okay, so we have the answer. A number divisible by 4 is 4 and 8. That means it is 233. Clear? Okay. Then a number divisible by 5. Find 0, but it can't be taken at first place. So it is 1, 2, 2. And now if we take a number divisible by 6. Is there any number divisible by 6? No, it is automatically divisible by 2 and 3, no? Okay. Is there any number divisible by 8? We'll take a 7 later on. Is there any number divisible by 8? No, it is automatically counted in 4 and 2. And 9 is also counted by 3. Clear? Okay. So we have these many data basically. Now 6 or 7 or 8 or 9, out of which 7 is the arising case. So what is this divisibility of 7? So for 7, you need to check the table of 7. You need to check it 6, 7, 8, 9 so that you will get the answer. Just think on what will be the 7 counting. Meanwhile, just count this one. Count each number and tell me the final answer up to this. At least up to this. Or means what, you are going to add this number. Yes or no? Or means what, you are going to add this number with the OR case of fundamental counting principle. Do it. What is the answer? Just add this 16 also. Why that 16? I'll explain. Just add this first. 900 plus 100 plus 48 plus 18. What is the total? 48, 18, 416. What is the final value? 1086, right? See here. Now see, we are considering the divisibility of three numbers. So 6, 8, 9 are the factors of another number. But these four numbers are divisible by itself only. So it is 4 into 4. These 4 digits are divisible by itself. So it is 4 into 4, 16 is added as in last count. Clear? Okay. So this is, if you could go through the one by one of this case, you will get to know that divisible by one numbers forming are 2 numbers forming are 100, divisible by 3 numbers forming are 48. Likewise, if we add on the all numbers, we are getting 1086, and this is a numerical based answer question. So you need to upload your solution 1086 in the JEE main questions. Clear? Okay.